Welcome. This is the third video in my series updating you on the status of solar cycle 25 as of May of 2022. And this video is about solar eruptions. The first two videos were about sunspots and the strong magnetic fields associated with them. Now, one of the consequences of strong magnetic fields on the sun is they store a lot of energy, and that energy can be released in a very sudden and dramatic way. And that's what creates solar eruptions. This is a picture of one of those taken in helium-2 304, showing, first of all, a flare just near the limb of the sun and a corresponding eruption of material away from the sun. Now, these eruptions are important energetically because there's a lot of energy involved in them, and they lead to something called coronal mass ejections. These are one of the things that cause aurora and geomagnetic storms on Earth. There are two types of eruptions. One is an eruptive flare, shown here on the right, where a large flare, like the previous one, blows a vast quantity of material into planetary space. As one of my colleagues calculated, the amount of material in this is the equivalent to 100,000 aircraft carriers traveling at 1,000,000 miles an hour. The second type of eruption is that from a filament or prominence. A prominence is a filament on the limb, and a filament is a prominence on the disk. So they're basically the same thing. It's just the perspective is very different. When they're on the limb, they appear bright, and when they're on the disk, they appear dark. This is because they have high density and absorbing ultraviolet emissions from behind them. So these two are different in the main sense that the first one has a flare, which produces a lot of radiant energy, plus a lot of kinetic energy. And the second one is basically the kinetic energy version, with generally not necessarily a very big flare. When you get both of these together, then you can get some extreme solar events. So let's take a look at a movie of the 304. It's going to be a 4-week movie in the transition region. That's a temperature of about 50,000 degrees. So that's a transition from the surface temperature, which is about 5,000 degrees, into the lower corona, which is of the order of 1,000,000 degrees. And you will see the prominences on the limb and the filaments dark on the disk, and then you will see some of them erupt away as they become unstable. I suggest you actually run through this part of the video 3 or 4 times, looking at the different quadrants of the sun, because there's so much going on all of the time. When there's one of these eruptions, they're often accompanied by what's called a long duration flare. Sometimes they'll go on for 4 or 5 hours, and that means they're producing a lot of energy for quite a long time. How can they do that? What makes them last so long? If you look on the right here, is what's called the standard model of a flare. You have a large loop or a filament here, that's the wavy line, contained by coronal magnetic fields. As this becomes unstable, they start to lift off. And as they do, the pressure from the surrounding corona pinches off the magnetic fields, and as they reconnect, they create hot loops below, shown here in red. And on the left, you actually see a sequence where you see the flare take off, and then these arcades of loops form towards the end of the event. And they continue glowing for hours and hours as higher and higher magnetic fields reconnect. As I said, these eruptions lead to coronal mass ejections. The pinched off field accelerates the coronal mass ejection, which flows out into the solar wind. And some fraction of them, not actually a very large fraction, can actually hit the Earth and cause geomagnetic storms. There's a particularly beautiful example here on the left. The bright areas are the coronal mass ejection, and you can actually see that dark area in the middle of it, and that's probably the remnants of the dense prominence that are lifted off to create this event. So what conclusions can we draw from this? A long duration flare indicates that a CME has been launched. The eruptions expel vast amounts of material and energy into interplanetary space. The main part from the flare is radiation, i.e. X-rays, UV, etc. And the main part from the CME is kinetic energy, that's material moving at very high speeds. And that energy, if it impacts the Earth, can affect us in terms of creating aurora and geomagnetic storms. Thank you for watching. Please stay safe, and until next time, goodbye.